Hello, welcome to Skill Set Engage. Today we're going to be going over the repair of a Maytag Bravos. Specific model number, if you're looking for it on your particular dryer, can be found usually on the inside of the door. This model number is an MEDX655DW1. Now, first and foremost, if you are doing electrical work, you should be confident in what you're doing. If you are not, don't do this. These machines often operate without us being immediately around them. That can create a fire hazard and put other people at risk if you assemble this in the wrong way. The system basically ended up with a sour spot that grew bigger and bigger until eventually all we had was a sweet spot to start it with. Basically what would happen is it would stop running, we could rotate the drum, and that would either affect the differential clutch on the motor, or it would in fact cause us to basically be in a better spot for the start on that. It could be a capacitor going out, could be a lot of things, but the reality is that whole motor assembly needs to be swapped out. Now, through a couple of diagnostics, we could determine that it wasn't the switch, because I could in fact click it down, rotate it, and start it and press there. That is a common switch to go out right there. And another part is your main control board. But since I'm able to start in general, there is a relay that exists in there, and that could also be it, but I don't think that's the case with this because us rotating the drum wouldn't have any effect on it. Some of the tools I'm going to be using, these are these non-marring crowbars. I don't know the brand. I think I picked them up from O'Reilly's. You can use them to pop some of the paneling. There's a couple parts where you're going to pop up along the sides here. This particular component is a part number W10396032. That is the part number that was spec'd for the replacement on this. In general, you want to match like part for like part. If you go with a knockoff or refurbished, there's a chance there could be an issue. Maybe it will be faulty. If you go for a like part, there will probably be very little that you would need to adjust. The plugins for these systems should be able to unplug from the existing like part and plug directly in this. There shouldn't be any jumpers that we need to undo, so hopefully that's the case. That's going to be our motor here. You'll notice you can see the windings here, and if we actually go forward up into here, there is something that you can kind of see, which is the differential clutch. It exists right inside here, and it clicks out when it gets up to speed, so it allows the capacitor to do what it needs to do, and then it clicks forward. There's an awesome video I'm going to do a link to. The guy's pretty amazing with his engineering talk, and he goes over the whole entire process for those if you're interested in him. That's a common part to go bad, and it's a part you can replace just that sometimes. He'll go over that in this video. That's not what I'm here to do. Let's start disassembling this guy. Standard prong plug, depending on where you're at. This may change. The voltage for residential here typically runs 240, 120, 240, and it's plus or minus nominal. So it's one of those situations where it may be 110, and it may be plus or minus a certain tolerance for the type of machinery that you're working with. 208 is not unheard of. In fact, this one says 120, 208, or 120, 240. So those are your options for wire up on this guy. But chances are, if you're 120, you're more likely also 240 with that split there. While there are two clips up here, there's other points that we are connected to that we actually have to disconnect before we're able to actually pop the lid here. First things first, watch drive it. Popping the tops. There we go. Oh, I was right on that clip there. No wonder it was angled. There we go. And that'll bring us into this open section here. Now what we're seeing here is we're seeing the drum. We're seeing the band that goes around it. Now the drum is kept in place by this front face shield, kind of wedging it between the back section here, and there's kind of like, it is just wide enough that it kind of over envelops this outer rim area here. So what we're going to do, we actually don't need this anymore, is we're going to pop our connector here. We're also going to come down here and we're going to see that we need another tool. So we got our new tool. The screw we're going to be going after is right over there. We have our 5/16 bit here. For disassembly, you can use a drill. You want to, for reassembly, at least to get the thread started, you want to use just a regular kind of like screwdriver or finger tighten them in and then go at it with the drill. Otherwise, you might cross thread things. That can always be an issue. Not all the time with machine screw or with machine intended screws. There's also a little connector tab, it appears. That's on this guy right here. That there, this releases forward, and we're actually able to pop this up because it locks in on the bottom, kind of on little hooks. Freed up that side. Okay, and freed up that side. All right, that removes the whole door assembly. We can see this guy kind of hanging off right here. Now, this is the next part we need to undo to get it free. And what you're going to see is you're going to see a tension mechanism there. Our goal is to just kind of pop that off there. It actually threads up through, so we're going to pop it off the motor right there, and that should get us the ability to free up that. A couple things to keep in mind. We're going to be looking at these rollers. We're probably going to replace that because this thing is tight. Always unplug equipment before you start messing with electronics. Green, typically your ground. Black and red can actually be both of your hots. White will be your neutral in any existence with regards to this. And that's sort of something to look out for. For the back nuts here, 1/4 bit should do the trick. So here's our next piece. Probably find some goodies in there. Fantastic. It's an area that things can pool. It's an area that blockage could happen. Something could lock up your fan there. So kind of look out for it. One of the things I had to do was take off this back retaining clip. And what I was able to do was basically hook the pliers up underneath there, kind of pry upwards, and that allowed it to be released. The issue I was having was I couldn't keep this from rotating with just a set of channel locks. So what I ended up having to do was basically lock onto it with some vice grips here and rotate. And a quick jerk that direction allowed it to break free, and now I'm able to pull the blower off. Probably should have left this part mounted to there. Probably would have helped with a little bit of stabilization. But for right now, I think we are okay. So what I'm going to do is I am going to set this guy down, or lock this guy back in place, and then I am going to rotate that thing off from the back side. There we go. Yeah, probably should have left it mounted, but we should be freed up. And that vice grip attached to there is preventing it from rotating further out. So we can free it. Go. There we go. A little bit marred up. You can get this replacement also if it becomes an issue, but I think we're okay. We're just going to sweep off these fins, make sure no debris catches onto there. Lint is kind of weird. It catches on everything, so the less it has to catch on, especially itself. I have a coworker who dealt with a lot of dryer stuff, and he talks about lint like it's some monster that exists almost, and like it just has a mind of its own. So, anywho, that's sort of what we got there. We freed up the motor. We could sort of clean up this area here. There's gonna be a lot of junk built up here. There's a screw probably from one of my projects. All sorts of stuff. But now that we got that freed up, we can scrape that, clean it, and we can get this motor replaced. Okay, something else is I wanted to get a new set of rollers because these ones, they just could really use a replacement. That would probably be why we're having trouble starting. And that's that centrifugal clutch that we talked about earlier. With that thing broken apart, this can't get there. So we might be able to fix this motor at some point, use it for something else. Let's get some things reinstalled. Now, I did look up online because I wanted to see from my own curiosity if there was a specific type of lubricant or no lubricant. Dry and dusty areas have a tendency of accruing material if it's a liquid. I And so far what I can find is don't use lubricant. If you do use lubricant, you can use a graphite type lubricant, just not a liquid type, because the dust and stuff will bind to it and it'll become more of an issue as time goes on. That's what we have. Here is, and that guy spins pretty darn decently. We're going to do the rest of these. Recommendation is replace the bearings while you're in here doing all this. Repairing a bearing pack is going to be like 15 bucks. So it's not the end of the world for you to go with it. You never know, it may save you some heartache. I may take a wire brush to that. It's a little bit of material buildup. That's night and day. That one spins a lot better, especially after scraping it. So that's definitely an area that could have been putting strain on the motor. So if the motor has to push through something heavy, like a bunch of clothes, and having to push through a heavy wheel that doesn't want to spin, that's just a level of pressure you don't need. One of the critical aspects that we're going to do is we're about to change this puppy out. So we're going to look at the connector pins. Sometimes you might have a similar connector on some electronics that you might not carry over to everything. So we're going to look at this guy. We have this lead, and this lead taken for special connectors. Sometimes there might be a jumper involved. We're going to look at where we land up in here versus where we're coming into. And you're going to see a very, very similar structure for this guy. So it's looking like the pinout is going to be the exact same. And we're re-verifying that our motors, W103, 96032, W103 96032. So we have the exact same part number. Okay, you want to have your torque set down as we go to tighten things. Up a little bit. Because you don't want to strip something out. Now, you should never start the thread. Some of these sheet metals or screws are meant to go in there, but you never really want to start a thread with the drill. You could start it with your fingers, get into place, and then start it. Sheet metal, though, it's meant to kind of go in and find its spot, but it's best if you take the same path that you took before. Let's get this guy back in here. Okay, that seems to be the sweet spot for him. All right, let's get this guy up and around, and that just binds right there. And I seem to recall having trouble getting the edge right there. Okay, my solution, because it was bowing out in one particular spot, is to spread out surface area. So I popped my drill in there, went around to the other side and rotated. I was able to get a pretty decent tightness there. Now, anything that spins is meant to have the threading kind of go the opposite direction. It's kind of a reverse threading. You'll see a lot on like anything that has a mobile like wheel or rotational axis or something else like that. And it's entirely dependent on the direction, so it'll kind of self-tighten. That's on a lot of applications. So this is where starting and stopping a project after a while, it makes logical sense to come through and do each of your screws in their spots, so you remember where everything kind of went. You could be left kind of at the end trying to figure out what's up. You can do cups that sort of label where everything goes, but in general, this is one of those things that can save you a lot of heartache. So we're going to grab this structure here. We're going to run it on up through and check to see if there's anything we want to clean before we get this done, since we have it out. There's a little bit there. But yeah, so next process here, sliding this puppy in, about that puppy. What are you doing? Hand thread first. Okay, you really want to have the torque down when you get to really thin sheet metal, because if you rip that out, you'll have to go up a screw size to be able to make it so the threads get in contact. We're going to check for rotational spin, make sure nothing's seized up. Anytime you're binding something together, usually probably not an issue with this, but we want to make sure we have free spin. We're almost to the final leg here, where we are about to assemble the last of this piece. We've got everything in place. Everything's locked in place and not going anywhere. Now, the critical aspect of this is, I'm going to emphasize, if you don't know anything about electricity, do not attempt this. Let somebody else do it. If you are familiar with electricity, obey the basic rules for when you're powering something up. I like to make sure that if I reassemble something, I don't operate it without anyone home. So number one, you can be there so you can cut the breaker power and then apply a fire extinguisher where applicable. It's just kind of proper safety etiquette. Not even that you installed something wrong. This could be a faulty part from the factory. There could be a piece of metal in there where it doesn't need to be. It causes a short. There could be a nick in some of this coating that's on the outside of these wires for these motors, and that causes a shorter inductive loop, which then in turn creates more heat. That heat pushes past the tolerances for the coating of that material. It'll actually melt that coating off, and then you'll get a faster or a shorter and shorter circuit until this thing bursts into flames, or hopefully your breaker pops. It all depends kind of how that whole setup of the cascade of failures. If it draws too much power for that the breaker pops, then you're safe. If it doesn't, if it's a slow melt and then catches fire, that's a whole nother matter. Dryer lint is very flammable. That's another aspect there, so it's something to keep in mind. So, I'm not responsible if you break your dryer. You do this at your own risk. When you go through and do the power-up processes, make sure that people know not to come up and, say they find you unconscious in front of the dryer that you just rewired. Make sure that somebody doesn't come up and touch you. The first thing it should do is know which breaker on the panel to flip and turn that whole section off. Then they can kind of assess and come up and try and take care of you. People will die because they try and be a hero when they don't assess everything that's going on in the situation around them. So, emphasizing this entirely, do not do this if you don't know what you're doing. And then further on beyond that is be safe. And I'm not responsible if you break your dryer. Home stretch here. You can already see where the belt's been. That also gives you a lot of frame of reference with regards to the rest of the structure here. You can see these grooves. These grooves are meant for those, the wheels there to go back in for the assembly there. All right, so we're going to rotate this around. With the belt on in approximately the same place, it'll kind of self-correct. So as it's on the belt and the tension pulley, it'll get guided towards this line right here where it's meant to be. And let's go ahead and get this puppy in. So I like to be working our way forward. Make sure the belt's not tangled. Okay. And we're going to find our little niche, because this guy goes right there. And alrighty. The way this is kind of held in place is the front end has to kind of fit around this part right here, which is a plastic piece that can be replaced too if it's damaged. But we got to actually get down below and into that setup. And it actually hangs pretty darn well, but I don't like leaving something with tension on it. I'll put a wrench there. We've come to the bitter end. I propped up the drum so we're not kind of pulling back on those wheels there, so we can kind of get in here and loop the belt where it needs to go. This wheel right here is what runs through, and it always kind of clips in a weird way. It doesn't seem natural. Alrighty. What we do is we need to actually come through and loop it through there. So it comes under this wheel here, kind of pulling in this direction, which applies reverse tension and loops through, around, and then back through. And that's sort of how this guy gets its grip. And there we go. Let's put this back for a quick second because we got to get the front end on. The front end clips onto these parts right here, just sort of slides in. I didn't get it on video, but what I had to do is I had to get one piece in and drop it in place, then come over and kind of wedge the other part and get it into place. Let's get that in place. Okay, let's get this guy in place. Okay, reconnecting our door switch. The door switch over goes out. It's an easy thing to fix. Basically, you should see the light inside go off if you have a light in there. And that is your indication that's kind of operational. So, fun stuff. All right. Now we're dropping this guy here. Now, this is a part that can hurt if you mess it up. So be very careful. If because the only way to get that screw out is to disassemble. There's another way to get it out. You turn the dryer upside down. Either way is not fun. And that's actually too far. So when you see that screw spin and there's nothing else going on, that means you've actually kind of stripped that hole. I went too far over to kind of undo the clip and I didn't undo the back. Luckily, it's not really load bearing. It should be fine. We got everything wired up. We've got our dryer vent hooked up. Make sure that's clear of any debris. That will put a strain on the system as well if it can't blow air. Later we may go through a video on clearing out the dryer vent for my straight pipe that I attached. Straight pipe versus the flexible will be less likely to kind of collect up lint. And, well, we've got it all plugged in, so now's the moment of truth. Light comes on. That's a good feature so far. And we are going to okay. Hopefully that sound is a little bit less intense as we go forward, but here's hoping that it's heating. So let's, we were on air fluff just a moment ago. We're gonna go to high. I definitely feel the heat there. So make sure our vent's hooked up correct. That's not pinched in any severe way. Okay. We should have heat. We definitely do. All right. Alrighty, so I think it worked out all right. The sound started to work itself out towards the end there, and sometimes that's the bearings getting their position in life with regards to that whole setup there. It heats, it rotates, so, and it starts. That's definitely a plus from where we were before. Relatively easy repair, swapping up like part for like part, so that kind of goes hand in hand with itself. But overall, other than time consuming a little bit, not too crazy. If this helped you out, guided you along with your repair, by all means, feel free to let me know in the comments, and hope you like this video. If you do, you know what to do. Till next time.